Hi guys, welcome to our video lecture series of Laplace transforms. So we are discussing about the inverse transforms, and we talk about some properties of the inverse transforms. We solved some examples and we learned a lot about the properties. So now I will solve some problems using the partial fraction method. That is the most significant method for the inverse transforms. So it will be helpful in taking the inverse transforms in the part of the differential equations and other applications. So using partial fraction is very easy. We have learned partial fractions in our previous classes. Let's take a question. Say that I have to find the inverse transform of 4s squared minus 3s plus 5, that is divided by s plus 1 multiplied by s squared minus 2s plus 2. So now we know that for partial fractions we have to break the function into parts. So I can say that 4s squared minus 3s plus 5 divided by s plus 1 multiplied by s squared minus 2s plus 2 is just equals to a over s plus 1 plus bs plus c divided by s squared minus 2s plus 2. So we have broken the function into two parts. So now we will solve it. First of all, I have to take the LCM of the function. So I will get the left hand side is same 4s squared minus 3s plus 5 over s plus 1 multiplied by s squared minus 2s plus 2 is equals to a over s plus 1 plus bs plus c over s squared minus 2s plus 2. Now the left hand side is same, and I can take the LCM on the right hand side, and what I get is this function bs squared plus bs plus cs plus c and whole divided by s plus 1 multiplied by s squared minus 2s plus 2. So this will be cancelled out by this function in the denominator, and we will left with 4s squared minus 3s plus 5 is equals to s squared. So I will arrange the terms: s squared terms, like term coefficients, minus plus s in the bracket. I will get minus 2a, then plus b, then plus c, and then the constants, that is plus 2a plus c. So now I have arranged the terms and I will compare the coefficients. So on comparing the coefficient of s square is a plus b on the right hand side, and on the left hand side is 4. So compare these coefficients. B plus c is equals to minus 3, then 2a plus c is equals to 5. Now we get three equations here, so we can solve it using simultaneous equations. So we can solve it using the simultaneous equation technique, and we can solve it by calculator. It's easy to solve using calculator. I am writing the coefficients directly. So a is equals to 12 over 5, b is equals to 8 over 5, and c is equals to 1 over 5. So now I can replace the coefficients that I suppose initially. So now the question will be converted into some easier form that I can solve it using the properties of inverse transform. So on the right hand side it will be 12 over 5 multiplied by s plus 1 and plus 8 over 5 multiplied by s divided by s squared minus 2s plus 2 plus 1 over 5 multiplied by s squared minus 2s plus 2. Now we see that now it's a lot easier to solve this problem. And if I take the first of all, before embarking into the inverse transform, I will just make some simplifications in the denominators. It is same as here, and then plus 8 over 5 multiplied by s divided by s squared minus 2s plus 1 plus 1. I broke this function into plus 1 because I will make a perfect square here, and then 1 over 5 multiplied by s squared minus 2s plus 1 and then plus 1. So now it's a lot easier to solve this function. We can see that it is 8 over 5 multiplied by s divided by s minus 1 whole squared plus 1 plus 1 over 5 multiplied by s minus 1 whole squared plus 1. Now we can take the inverse transform of this function easily. So now I will apply the inverse transform. So when I will apply the inverse transform on this function, so I can write it as Laplace inverse transform of 12 over 5 multiplied by s plus 1 plus 8 over 5 Laplace inverse transform of s over s minus 1 whole squared plus 1, and then the Laplace transform inverse transform of 1 over s minus 1 whole squared plus 1. Now it's a lot more easier, and its simplified form. We can see that this function can be transformed easily. 12 over 5 multiplied by s plus 1, and then this function, for this function in the denominator I can see that it is s minus 1 whole squared, so I have to make it compatible in the numerator. So what I will do is I will add 1 and subtract 1 in the numerator. So this is 12 over 5 Laplace inverse of 1 over s plus 1 multiplied plus 8 over 5 Laplace inverse s minus 1 plus 1 divided by s minus 1 whole squared plus 1, and then the last part is 1 over 5 Laplace inverse 1 over s minus 1 whole squared plus 1. Now we can see that this function is a lot more compatible in the numerator. And now some more simplifications that is now I will take the inverse transform of this function, so it will be e raised to the power negative t plus I can write 8 over 5 Laplace inverse s minus 1 divided by s minus 1 squared plus 1, and plus 8 over 5 Laplace inverse of 1 over s minus 1 whole squared plus 1, and then 1 over 5 Laplace inverse of 1 over s minus 1 whole squared plus 1. So the inverse transform of s minus 1 over s minus 1 whole squared plus 1 can be found easily by using the shifting property. So we know that the Laplace inverse of this function will be e to the power t multiplied by cos of t plus 8 over 5. The inverse transform of this function will be e to the power t multiplied by sine of t plus 1 over 5 into e to the power t multiplied by sine of t. So We are now a lot more closer to our answer. Even we have got our answer, but we'll simplify some things here for easy understanding, and we will take 8 over 5 as common, and e to the power t common as well, so we will left with cos t plus sin t in the brackets, and then plus 1 over 5 e to the power t sine t, and this 1 over 5 t e to the power t sine t can be added to this sine t, and we will get the final answer. Then even you can write it as the final answer, but you can simplify. It's good to simplify the answer. So we have learned the inverse transform using partial fractions, so I hope you get some concepts from this lesson, and we'll come up with a new lesson in the next lecture, and we'll talk about some convolution theorem. Thank you guys for listening and watching. Thank you.